Question 1. In the context of integrating third-party systems into an existing BAST platform, which of the following best illustrates a proactive approach by a technician when facing interoperability issues between a Modbus-based VFD and a BACnet-native BAST network? A. Replacing the VFD with one that natively supports BACnet to match the BAS. B. Using a Modbus to BACnet gateway and verifying communication using protocol diagnostic tools. C. Installing an additional BAS controller configured to speak both protocols simultaneously. D. Programming a workaround using manual overrides in the user interface to mimic integration. Answer. Correct answer. B. Explanation. When integrating systems using different communication protocols, a protocol gateway. G. Modbus to BACnet is a common and efficient solution. Tools like protocol analyzers or network diagnostics software help ensure the gateway is correctly configured and communication is functional. Replacing hardware, option A, may be costly and unnecessary, while adding a controller, option C, is inefficient and create redundancies. Manual overrides, option D, undermine system automation. According to ASHRAE Guideline 13 and BACnet standards and ASHRAE 135, protocol gateways are a standard, scalable approach. Question 2. As demonstrated by a recent installation project, Jasmine is programming a PID loop for a valve box to maintain a specific discharge air temperature. She notices that the system is oscillating around the set point. What is the most likely cause of the oscillation? A. The proportional gain is too low. B. The interval time is set too high. C. The derivative gain is too aggressive. D. The feedback sensor is incorrectly placed. Answer. Correct answer. C. Explanation. Oscillations in a PID loop often indicate tuning issues. In this case, an overly aggressive derivative gain amplifies the rate of change, causing overcorrections, while the integral and proportional components options A and B can also impact stability. They typically cause drift or sluggish response, not oscillations. Incorrect sensor placement, option D, affects measurement accuracy but doesn't inherently cause oscillation. Refer to ISA PID tuning standards and ASHRAE controls guidance for tuning methods. Question 3. Given the circumstances, Mr. Alvarado is troubleshooting a newly commissioned BAS system where multiple temperature sensors on a BACnet MRTP network are dropping offline intermittently. Which action should he take first? A. Increase the polling rate of the devices to ensure faster data collection. B. Replace all sensors, assuming they are defective. C. Use a BACnet protocol analyzer to identify token passing failures or data collisions. D. Reprogram the BAS to bypass the offline sensors. Answer. Correct answer. C. Explanation. Intermittent drop-off on MRTP networks often point to issues like improper terminations, addressing conflicts, or data collisions. A BACnet protocol analyzer helps identify where token passing is failing or excessive retries are occurring. Increasing polling rate, option A, worsens the issue. Replacing sensors without diagnostic confirmation, option B, is wasteful. Bypassing sensors, option D, under system integrity. BACnet MRTP follows strict rules for token passing and network health diagnostics. ASHRAE 135-2020. Question 4. According to recent studies, which of the following scenarios demonstrates correct sensor calibration technique for a supply air temperature sensor installed in a rooftop unit during commissioning? A. Calibrating the sensor using ambient room temperature as a reference. B. Substituting a sensor from another rooftop unit with an assumed working value. C. Comparing the sensor reading to a calibrated handheld thermometer placed in the airstream. D. Relying on the BAS system default calibration settings without verification. Answer. Correct answer. C. Explanation. Proper calibration involves comparing sensor output to a reliable and calibrated standard such as a high-accuracy handheld thermometer in the same environment. Using ambient room temperature, option A, doesn't replicate duct conditions. Swapping components without confirming accuracy, option B, introduces uncertainty. Trusting factory settings, option D, ignores potential field variability. Per ASHRAE Stat 111 and NEP commissioning protocols, field verification is essential for reliable BAS operation. Question 5. When faced with a scenario involving energy performance issues, Istakata is reviewing historical BAST trend data and notes that the chiller continues to operate overnight despite the building being unoccupied. What control strategy should he investigate or implement to correct this? A. Static setpoint scheduling for discharge air temperature. B. Demand control ventilation override. C. Optimal start-stop based on building thermal load prediction. D. Night purge ventilation strategy. Answer. Correct answer. C. Explanation. Optimal start-stop logic allows equipment to operate based on predicted load and building thermal inertia, preventing unnecessary operation during unoccupied periods. Static schedules, option A, lack adaptability. Demand control, option B, is occupancy-driven ventilation and unrelated to chiller operation. Night purge, option D, is used to pre-cool spaces using outside air, not to stop chillers. ASHRAE Guideline 36 and ASHRAE 90.1 emphasize predictive control strategies for energy efficiency. Question 6. In light of recent developments, which of the following is most critical to verify during the programming of an alarm management system in a BAST? A. That alarms are color-coded by severity. B. That all alarm messages have long, descriptive texts. C. That alarm priorities, conditions, and reset behaviors are clearly defined. D. That alarm acknowledgement requires a password. Answer. Correct answer. C. Explanation. Well-defined alarm logic ensures effective system monitoring of fast response times and operator clarity. Alarm priority, trigger conditions, delay timers, and reset logic must be set correctly to avoid nuisance alarms or missed faults. Colors, option A, and long messages, option B, are helpful but secondary. Password protection, option D, is part of security but not core to alarm logic. IS 18.2 and ASHRAE BACnet Addendum. Alarm configuration must follow structured practices for clarity and reliability. Question 7. While examining the HVACR components of a building's automation design, which of the following explains why variable frequency drives VIV-FDS are more compatible with VAV systems than constant volume systems? A. VIV-FDS eliminate the need for static pressure sensors. B. VIV-FDS allow modulation of fan speed based on demand, aligning with VAV requirements. C. VIV-FDS provide constant airflow, which is ideal for VAV systems. D. VIV-FDS replace the need for terminal box control in VAV designs. Answer. Correct answer. B. Explanation. VAV systems benefit from VIV-FDS because they adjust fan speed based on demand, saving energy and reducing mechanical wear. Constant volume systems don't vary airflow over FD. Benefits are minimal. Static pressure sensors, option A, are still required. Option C misrepresents the purpose of VAV. Variable airflow, VIV-FDS complement, not replace. Terminal box controls, option D. ASHRAE 90.1 mandates fan power control in systems with modulation capabilities for energy savings. Question 8. From a practical standpoint, which network topology would offer the most resilient design for a large BAST network requiring fault tolerance and easy expansion? A. Star topology with centralized switches. B. Ring topology with redundant paths. C. Bus topology using daisy-chained RS-485 devices. D. Tree topology with single-path branches. Answer. Correct answer. B. Explanation. Ring topology provides redundancy. If one link fails, communication continues in the opposite direction. Star, option A, offers centralized control but is vulnerable to switch failure. Bus, option C, is simple but prone to complete network drop with one cable break. Tree, option D, suffers from single-point failures. E800 2.1 and its redundancy guidelines support ring topology with self-healing capabilities for mission-critical BAST networks. Question 9. As a result of misconfigured system logic, Tanaka notices that the heating and cooling systems are both running during mild weather conditions. What underlying issues should be addressed in the BAST programming to resolve this? A. Adjust the outside air damper minimum position. B. Implement deadband logic between heating and cooling set points. C. Calibrate the room humidity sensor. D. Increase the space temperature cooling set point. Answer. Correct answer. B. Explanation. Deadband logic prevents simultaneous heating and cooling by creating a neutral zone where neither is active, avoiding energy waste. Adjusting damper position, option A, addresses ventilation, not temperature control. Conflict, humidity sensor calibration, option C, is irrelevant here. Changing a set point, option D, doesn't solve the underlying logic flaw. HRConquer Guideline 36 specifies the use of proper deadbands in BAST programming to optimize energy use and avoid conflicting outputs. Question 10. The core principles of BACnet communications emphasize which of the following advantages for BAS interoperability in multi-vendor environments? A. Proprietary encryption protocols for security. B. Use of cloud-based configurations for all devices. C. Defined object types and services enabling consistent data exchange. D. Exclusive compatibility with native BACnet controllers only. Answer. Correct answer. C. Explanation. BACnet building automation and control network enables interoperability by defining standard object types, e.g. analog input, and services, e.g. read property, ensuring consistent behavior across devices. Proprietary protocols, option A, undermine openness. Cloud usage, option B, is not a BACnet core function. BACnet supports multi-vendor devices, not just native controllers, option D. BACnet is standardized under HRConquer 135 and ISO 164845. Question 11. When evaluating the merits of BAS controller configuration for a large hospital, a technician finds the control sequence causes HVAC equipment to restart after a short power interruption. What is the most appropriate configuration setting to mitigate this? A. Enabling manual override on all outputs. B. Implementing a time delay restart logic in the controller programming. C. Reducing the polling interval to increase controller responsiveness. D. Disabling all alarms during power-up sequence. Answer. Correct answer. B. Explanation. A time delay restart prevents equipment from cycling too quickly after power restoration, protecting components like compressors and fans. Restart delays reduce inrush current and potential damage from short cycling. Manual overrides, option A, aren't scalable in emergencies. Polling intervals, option C, affect communication frequency, not startup logic. Disabling alarms, option D, delays detection. NFPA 70, NEC Article 430 and HRConquer control sequences recommend staggered, delayed equipment restart to prevent overload. Question 12. In a modern context of smart building integration, Mr. Green is tasked with implementing a demand control ventilation DCV strategy in a school gymnasium. Which sensor is most critical for effective DCV operation in this space? A. Supply air temperature sensor. B. Co-concentration sensor. C. Return air humidity sensor. D. Static pressure sensor. Answer. Correct answer. B. Explanation. DCV strategies rely on co-sensors to determine occupancy levels and modulate ventilation accordingly. In high occupancy spaces like gyms, co-levels indicate the need for increased outside air, enhancing IAC and energy savings. Temperature, option A, and humidity, option C, are secondary to occupancy detection. Static pressure, option D, supports valve control. The DCV HRConquer Standard 60.1 mandates co-based control for densely occupied spaces in DCV applications. Question 13. Considering the evidence, which of the following would most likely indicate a sensor fault when reviewing a building automation trend? Log A. Sensor values fluctuating predictably with time of day. B. A constant sensor value despite expected environmental changes. C. A value that aligns exactly with the program set point. D. Readings that temporarily spike during equipment operation. Answer. Correct answer. B. Explanation. A constant value regardless of expected variation suggests a faulty sensor or communication failure. This stuck signal could stem from wiring issue, failed sensor element, or software error. Predictable fluctuations, option A, are expected. Match with set point, option C, can be coincidental or normal. Temporary spikes, option D, may be real-time responses to load changes. BAS technicians use analysis for fault detection per HRConquer Guideline 36 and NEB protocols. Question 14. To illustrate this point is Delgado's diagnosing irregular air handling unit behavior where the system continues running in override mode even after the scheduled override time expires. Which of the following is the most likely root cause? A. The override duration was not assigned in the programming logic. B. The BAST clock is synchronized with the NTP server. C. The schedule is properly assigned and prioritized. D. The override function is disabled in the controller firmware. Answer. Correct answer A. Explanation. If override duration isn't defined or incorrectly set in the logic, the system may remain in override indefinitely. Synchronization, option B, supports scheduling but doesn't enforce durations. If scheduling, option C, is correct, the issue lies elsewhere. Firmware disabling, option D, would prevent override altogether, not extend it, according to BACnet priority arrays and ASHRAE 135. Point. Override functions must include both duration and reversion priority. Question 15. During the process of commissioning a multi-zone HVACR system, ISTASYNC observes temperature swings in certain zones. After eliminating hardware faults, which of the following programming adjustments is most likely to stabilize zone conditions? A. Disabling proportional control and enabling on-off control. B. Increasing the PID loop's proportional gain. C. Reducing the interval time to 0. D. Adjusting the PID loop to include suitable deadband. Answer. Correct answer D. Explanation. A deadband in a PID loop prevents frequent switching around the set point, reducing temperature swings in equipment wear. Disabling proportional control, option A, removes fine adjustment capability. Increasing gain, option B, can amplify oscillations. Reducing integral time to 0, option C, introduces rapid accumulation of error, worsening instability. ASHRAE PID control best practices recommend tuning with appropriate deadbands for thermal comfort and control stability. Question 16. A critical examination of system security reveals that the BAST network is accessible via default manufacturer credentials. Which of the following is the most appropriate corrective action to comply with cybersecurity best practices? A. Enable guest access with read-only permissions. B. Isolate the BAST network from the IT infrastructure. C. Replace default credentials with strong, unique passwords. D. Disable password protection to improve user access speed. Answer. Correct answer. C. Explanation. Default credentials are a major cybersecurity vulnerability. Best practices from NIST SB 80082 and ISAC 62443 require immediate replacement with strong, unique passwords. Guest access, option A, still presents a risk. Isolation, option B, helps but doesn't eliminate credential risks. Disabling security, option D, violates cybersecurity principles. Changing passwords is the fastest and most direct mitigation strategy against unauthorized access. Question 17. In comparison with other sensor calibration methods, which of the following is the most accurate approach for field calibration of a humidity sensor in a critical lab environment? A. Using room humidity as a baseline reference. B. Relying on the factory sensor curve without field verification. C. Calibrating using a NIST traceable hygrometer under actual room conditions. D. Adjusting based on user comfort feedback. Answer. Correct answer. C. Explanation. NIST traceable instruments provide certified accuracy essential for calibration in sensitive environments like labs. Room humidity, option A, is uncontrolled and unreliable. Factory calibration, option B, may drift due to environment or handling. User feedback, option D, is subjective and unsuitable. NEB and ASHRAE commissioning guidelines require calibration against traceable standards for precise operation. Question 18. During a system integration task, ISTA also notices that a lighting control system isn't communicating with the BAS despite being connected. The lighting controller uses BACnet while the BAS is configured for METP. What is the most likely issue and solution? A. Replace the lighting controller with an METP-compatible device. B. Install BACnet router to bridge METP and IP networks. C. Adjust the baud rate on the BAS to match the lighting controller. D. Configure the devices for auto-discovery on the same subnet. Answer. Correct answer. B. Explanation. BACnet and METP are separate data link layers. Communication requires a BACnet router to bridge the two. Replacing hardware, option A, may not be feasible or efficient. Baud rates, option C, apply only within METP. Auto discovery, option D, applies only within the same protocol. HRConquer 135 mandates proper use of BACnet routers for cross-layer interoperability. Question 19. Throughout the course of a site-wide BAS upgrade, which of the following IP addressing methods ensures consistent communication and minimizes conflicts across hundreds of BAS devices? A. UAP to dynamically assign addresses to all devices. B. Assign static IP addresses using a documented scheme. C. Allow each technician to choose their own addressing scheme. D. Use IPv addressing for simplicity. Answer. Correct answer. B. Explanation. Static IP addressing with documentation ensures stability, prevents IP conflicts, and simplifies maintenance. IEP, option A, introduces variability and can break communication if addresses change. Uncoordinated technician-assigned addresses, option C, lead to inconsistency. HIP, option D, isn't widely adopted in legacy BAS infrastructure. BACnet deployment best practices recommend structured, static addressing for scalability and supportability. Question 20. Illustrated by a commissioning report, a newly installed chiller control panel isn't responding to setpoint commands from the BAS. All network connections are verified. Which of the following is the next logical step in diagnosing the issue? A. Reboot the BAS server to refresh all controllers. B. Verify the command priority array within the chiller controller. C. Replace the network cable between the chiller and switch. D. Adjust the polling rate to increase command frequency. Answer. Correct answer. B. Explanation. In BACnet command, conflicts can occur due to overlapping priorities. If a manual override or higher priority command is active, the BAS command won't be executed. Rebooting, option A, is disruptive and rarely resolves priority issues. Cable replacement, option C, is unnecessary if communication exists. Increasing polling rate, option D, doesn't address command hierarchy. HRConquer 135 explains how BACnet devices handle command priorities using 16-level array. Question 21. The traditional approach to trend logging in BAS focuses on critical operational data. Cortez has configured temperature trend logs for multiple zones, but the logs are rapidly consuming storage space. What strategy should he apply to optimize storage without sacrificing diagnostic value? A. Log all points at maximum polling rate. B. Use change of value (COV) logging for analog points with defined thresholds. C. Increase the logging resolution to 1-second intervals. D. Delete all historical data after 24 hours. Answer. Correct answer. B. Explanation. COV logging captures values only when a defined threshold is exceeded, significantly reducing storage use while retaining useful data. Logging at max rate, option A, or 1-second intervals, option C, is wasteful and unnecessary for temperature trends. Deleting data every 24 hours, option D, defeats the purpose of trend analysis. BACnet and HRConquer Guideline 13 recommend efficient trend logged using COV strategies for analog points. Question 22. When analyzing a communication fault on a BAS network, Jenkins observes multiple METP devices not responding. Termination and addressing appear correct. Which of the following is most likely the next logical diagnostic step? A. Verify that only one device is set as the token master. B. Measure the RS-485 voltage differential using a multimeter. C. Remove all devices except the first and last to isolate the issue. D. Upgrade all controller firmware. Answer. Correct answer. B. Explanation. Measuring the RS-485 amp voltage differential should be between 1.55 of can identify wiring faults or bus shorts. Only one token master, option A, is not required in METP as token rotates. Removing devices, option C, is useful but premature without electrical testing. Firmware upgrades, option D, won't solve physical layer problems. Per I-485 and BACnet METP specs, checking electrical integrity is essential in network fault diagnostics. Question 23. With the advent of advanced analytics, which of the following scenarios best demonstrate effective use of trend data for predictive maintenance in a BAST? A. Triggering alarms when equipment fails. B. Using trend logs to confirm setpoint compliance. C. Analyzing energy usage spikes to predict mechanical failure. D. Monitoring humidity levels during weekends. Answer. Correct answer. C. Explanation. Predictive maintenance relies on identifying abnormal patterns, like energy spikes, which may signal failing motors, clogged filters, or other inefficiencies. Alarms, option A, react to failure, not predict it. Setpoint compliance, option B, doesn't indicate where. Humidity on weekends, option D, isn't typically predictive. ASHRAE Guideline 36 and FDD, fault detection and diagnostics frameworks emphasize using trend data to preemptively address faults. Question 24. Through careful analysis of a control strategy, is Blake notices that simultaneous heating and cooling are occurring in a mixed-use building, which programming enhancements should be implemented to prevent this condition and improve energy performance? A. Set all valve boxes to heating-only mode. B. Introduce occupied and occupied schedules per zone. C. Add a sequencing logic with heating-cooling interlocks. D. Increase the cooling set point by 5 deg. Answer. Correct answer. C. Explanation. Heating cooling interlocks prevent concurrent operation of opposing equipment, a major energy efficiency fall. Occupancy schedules, option B, help manage runtime but don't prevent overlap. Valve limitations, option A, reduce flexibility. Set point changes, option D, may temporarily mask the problem but do not resolve the control logic conflict. ASHRAE 90.1 and Guideline 36 recommend interlock sequences to optimize BAS efficiency and prevent unnecessary energy use. Question 25. Among the various BACnet object types, which is most appropriate to use when controlling a variable speed fan and needing both command and feedback functions within a BAS? A. Binary output. B. Analog value. C. Analog output. D. Multi-state input. Answer. Correct answer. C. Explanation. Analog output is designed for modulating devices like VVFDS, enabling variable control with feedback via associated inputs. Binary output, option A, is on-off only. Analog value, option B, stores a value but doesn't output to hardware. Multi-state input, option D, is used for devices with multiple discrete statuses. BACnet protocol ASHRAE 135 defines out for dynamic analog control scenarios like VFD fan operation. Question 26. Scholars have debated whether open BAS protocols truly ensure vendor interoperability. Which of the following factors most commonly undermines BACnet interoperability across devices from different manufacturers? A. BACnet does not support analog objects. B. Each vendor uses different physical wiring standards. C. Devices implement different subsets of BACnet services and objects. D. BACnet only works on Ethernet networks. Answer. Correct answer. C. Explanation. Vendors may selectively implement BACnet services, e.g. repropagate multiple trend log or object types, leading to partial incompatibility even under the BACnet umbrella. Analog objects, option A, are supported. Wiring, option B, is standardized under RS485 or Ethernet. BACnet operates on multiple transport layers, not only Ethernet, option D. ASHRAE 135 Annex K addresses interoperability challenges due to differing implementation choices. Question 27. Based on the information gathered from energy audits, ISTA-NG is tasked with implementing an optimal stop strategy for a larger air handling unit. What is the primary principle behind optimal stop? A. Stopping the system as soon as occupancy ends. B. Using predictive models to stop systems before setpoint drift. C. Programming a fixed timer to shut down equipment. D. Linking shutdown to manual user override. Answer. Correct answer. B. Explanation. Optimal stop uses building thermal inertia and predictive control to shut down systems just before the end of occupancy while still maintaining comfort. This saves energy without sacrificing performance. A fixed timer, option C, lacks adaptability. Manual override, option D, introduces user error. Stopping as soon as occupancy ends, option A, risks premature shutdown. ASHRAE Guideline 36 promotes predictive sequences like optimal stop for efficient control. Question 20. One might argue that valve terminal box calibration is unnecessary post-installation. However, what condition would most strongly indicate recalibration is required during commissioning? A. The damper modulates consistently from 0.100% during operation. B. The airflow reading does not match design CFM despite full damper opening. C. The box actuator moves smoothly and without noise. D. The heating coil activates under full demand. Answer. Correct answer. B. Explanation. If the airflow sensor shows values below design despite the damper being fully open, calibration is likely needed. This may be due to pressure sensor drift or actuator misalignment. Damper modulation, option A, alone doesn't guarantee accuracy. Actuator motion, option C, is mechanical but doesn't verify airflow accuracy. Heating coil function, option D, is unrelated to airflow calibration. NEB and TAP guidelines require airflow calibration verification during commissioning. Question 29. In response to a scheduling complaint, HRConquer is reviewing the BAST time synchronization settings. Which of the following steps is most critical to maintaining synchronized schedules across all networked BAST devices? A. Setting local time on each controller individually. B. Disabling automatic daylight savings adjustments. C. Synchronizing all devices using a centralized NTP server. D. Assigning different time zones to controllers by location. Answer. Correct answer. C. Explanation. Using a network time protocol NTP server ensures all controllers stay in sync, which is critical for coordinated schedules and logging. Manual time setting, option A, is error-prone. Disabling DSD, option B, causes seasonal drift. Assigning varying time zones, option D, leads to misalignment in multi-controller systems. BACnet supports time synchronization services, and ASHRAE guideline that recommends centralized clock management for BAS. Question 30. The underlying principle of feedback loops in HVACR systems ensures control accuracy. Which of the following issues most likely results from a missing or failed feedback signal in a BAS-controlled heating loop? A. The heating valve remains closed regardless of demand. B. The system continues to heat excessively without reaching set point. C. The loop switches to cooling mode. D. The fan shuts off unexpectedly. Answer. Correct answer. B. Explanation. Without feedback, the controller cannot verify if the heating output is affecting temperature, leading to excessive heating as the loop keeps increasing output to reach set point. Closed valves, option A, suggest a different fault. Cooling mode, option C, switching depends on sequencing logic, not missing feedback. Fan behavior, option D, is unrelated to the heating loop sensor feedback. BAS PID loops depend on real feedback for accurate modulation.